we're going to head out to the Harold R. Benson Research and Demonstration Farm, where we'll hear from Research Associate Karen Friley as she shares all the research they're doing on KSU's farm.
This is one of our native perennial border rows. There's a border row on this side and then on the other side. We have 4 of these plots that are bordered by native perennial plants and 4 plots that are just bordered by pasture. These plants are native to Kentucky. This is a rattlesnake master, and this is the actual flower. And right here is a wasp. These tiny grasses are little blue stem. This is Slender mountain mint. And here's bee balm. This had a light purple flower on it earlier. We chose plants that would flower. Something would be flowering throughout the growing season. So that's why these plants were chosen. Here is a thimbleweed, and it just shoots up one flower, but it's got an interesting leaf. What we're trying to do with these flowering plants is attract beneficial insects. Beneficial insects will eat pollen and nectar when prey is not available, so we're trying to bring in the beneficial insects. And then when prey shows up in the blackberries, these insects will hopefully move in. We have a new pest insect of blackberries called the spotted-winged Drosophila. It's a tiny, tiny fruit fly. And the female oviposits her egg inside a ripening or ripe blackberry. That egg hatches, and then the larvae proceed to eat the berry from the inside out. Growers will come to harvest the blackberries, and the berry looks completely healthy. And so they pick all these, but there can be larvae inside the blackberries. So this is common bone set. I've seen a lot of soldier beetles on this, but not today. And we've got more rattlesnake master. This actually is a New England aster with one little tiny flower here. This, we are collecting data using sticky traps and pan traps. Sticky traps will catch any flying insect, and the pan trap is specifically to collect parasitic wasps. Those wasps are very, very tiny. When they get stuck on the sticky traps, they're really hard to identify because a lot of the identification involves wing venation. So we have started using pan traps that is a 20% mixture of low-tox antifreeze and water. So we're trying to see what beneficial insects are here. As you see, we've got quite a big group of grass. This is mainly big blue stem and switchgrass. Grasses don't flower, but we chose to put them in here because grasses create microclimates for the insects, so they're protected from rain, they can get shade, and they're protected from prey. This is called a gray-headed coneflower. As time goes on, the centers of the flowers will turn gray, even though what you usually focus in on is the pretty yellow petals. Now here is a nice New England aster where you see the pretty purple flowers. And then right here is Foxglove beard tongue, and it's really associated with this plant here, but here's the flower of it. And these are the seeds. These were the first to bloom this season. These aren't blooming yet. They are beautiful. It's called blue Lobelia, and it shoots up a nice purple flower kind of a cone shape. Here's another, I'm gonna have to crawl through. But here's another foxglove beard tongue that's still blooming, and these were the first to flower, I think in May. And then we've got prairie dropseed. It's another grass. These are our blackberries. They're prime arc traveler. This is a second year growth. We planted them last year. You will see that there's some damage here, and that's from Japanese beetle. Japanese beetle are very heavy this year. The sticky trap and pan trap, this is the data we collect. We're looking at beneficial insects. On the sticky traps, we're looking at all lady beetles. We're looking at big-eyed bug and minute pirate bug that is very, very tiny. Those are the main insects that we find on these traps. The pan traps are collecting parasitic wasps that are very tiny. These wasps will insert an egg inside a pest or on top, and that egg hatches and ends up eating the pest. So these are collected weekly. The pan traps are set out for 4 days, and the sticky traps are set out for 7 days. We take them back to the lab, and we look at them under the microscope. And we have to sort out the parasitic wasps from any other insect that has fallen into the pan trap. And then Kyle identifies each wasp and puts them in vials. These blackberries, there are 2 rows per plot. They're about 80 feet long, and they were planted every 2 feet. We came back and marked 12 feet sections with these T-posts for treatments. We've got 4 treatments and 1 control. Then what we did to separate the treatments, we actually cut out the blackberries that were here. That separates the treatments, and it allows us to walk back and forth without having to walk the entire length of the blackberries. I was going to show you the spotted-winged Drosophila trap. These are handmade, and all that is in there is apple cider vinegar. Spotted-winged Drosophila are attracted to it, and we put 1 trap out per plot and change it every week, and we're monitoring to see if the spotted-winged Drosophila is here and if it's increasing. They are in these plots, but the numbers have not gone up tremendously yet, but they will.